isn't too bad to start with. It will get harder. And I wanted to show you some problems like this. Okay, the first thing we're going to do is, I always get a kick out how math makes wording so hard to understand. Most of the time when I give a definition in math, I don't care if it's this class, calculus, whatever, is, you give I give them the definition for the book, and then I will say, in other words, it means this. You know, like, for example, I'll give a definition that says, a function polynomial is increasing if f of x is greater than f of c in all the parts of the domain of f of x. Okay, that was the definition. And it's okay. And in other words, if it's going up to the right, it's increasing. You know, put it in layman's terms. What does it mean? If it's going up to the right, it's increasing. You know, and that's kind of like here. For radical expressions, like radicals have the same radicand. Unlike radicals have the same, do not have the same radicand. It's like, okay, what is that means? In other words, like radicals have the same number underneath that square root symbol. That's what like radicals are. If the numbers are not underneath the same, underneath the same square root symbol, they're not like radicals. Our goal is, our hope when we do these problems is that they are the same. Makes life a lot easier. Okay? And what I mean by that is this. It says combining like radicals. We're going to use a whole bunch of properties here and simplifying equations down. So first of all, square root of 2 plus 3 square root of 2. You look underneath the square roots. Are they the same? Now let's move to the top. Now what I want you to do is think about square root of 2 as an x. Okay? So if that was just plain x, that would have like 1x plus 3x, which would be 4x, correct? Do you agree? It's kind of the same setup. 1 square root of 2 plus 3 square root of 2 is 4 square root of 2. That's all we're doing. So we got one of these. We got one over here. We add 3 more on, we're going to get 4 square root of 2. That's simplified. Can we break down a square root of 2 any? No. Simplify it down. Can't go any further. Like the bottom one, same thing. You know, subtract is set up the same way. You got a negative 3 square root of 5 minus 4 square root of 5. Now, a lot of people don't like subtracting as much, so I just put a plus and minus here. So I got negative 3 square root of 5 plus a negative 4 square root of 5. Is it? Negative 7. Negative 7. Negative 3 plus a negative 4 is a negative 7. Square root of 5. Can we break down square root of 5? No. Some of these we can't show work, but I do want you to see work as much as possible. I don't want you to just punch in the calculator and get an answer. I want you to show me some work too as you go. But these are hard. You know, most of you can do that in your head, right? See how hard this is? Can you do it? What? Can you do these problems? Should we do that? What's wrong with those?
Now you have to simplify down the square root of 12 so that it's combinable with the square root of 3.
First of all, let's go step it back. If I look at this problem to start with, I got 7 square root of 3 minus square root of 12, right? Let's go back to that definition we started with, unlike radicals. Can't combine them if they're unlike, right? As they are right now. Now what Gavin said is, maybe, now it doesn't happen all the time, but maybe we can make them the same. And what he's saying is, let's take the square root of 12 and break it down into the square root of 4 and the square root of 3. Okay? And square root of, because 4 times 3 is 12. Now wait, take a second. Where did that come from? How do we know to do that? First section of this chapter, right? First section. We're going back to that first section and combining some concepts. Now if I go here and I got 7 square root of 3 minus, okay, square root of 4 is 2 square root of 3. I'm hoping you write these down as we go. 7 square root of 3 minus 2 square root of 3, right? Now, are they the same? Yep. Now we can subtract them. So if we subtract these, we're going to get 5 square root of 3. Now, can I simplify that down any?
No.
No, can't simplify that.
Maybe I just haven't taken notice, but have all of them been minus in between the two sides?
So it doesn't matter if it's minus or plus. Either one works.
Okay.
It might have been all minuses. Like the next one is plus, but this set up the same way. Try the next one. We're not set up the same right now. See what you can do. Like I said, first of all, could we combine them as they are? No. So we're looking at the one that's a little bit bigger number usually, right? It could be both. We might have to simplify both down. But square root of 20 is,
Square root of 4 and square root of 5.
okay. Now I want to think about that for a second. You said square root of 4 and 5 is right, okay? Then somebody asked me this morning, so why don't we do 2 and 10?
Wouldn't that be more set?
It'd be more simple, but does either one have a square root?
No, they do.
The 2 and 10 doesn't have a square root, right?
You'll have to break down the 10 again.
Yeah. And we don't want to break down, when we break down a number here, I don't care what it is. Even if it's going to be different from this one, even if it's going to be different here, I don't care. We still break these down according to if it has a square root, it doesn't, okay? When we look at 20, we have 4 and 5, and square root of 4 is 2, and 2 times 3 is 6, square root of 5, plus 2, square root of 5. So we break it down. This one does work because both are square root of 5 now. 6 square root of 5 plus 2 square root of 5 is
8 square root of 5.
8 square root of 5. Break it down. Okay?
How do you do them if there's no numbers up front and they're not the same?
We'll get to some of those in a second, okay? FOIL, or distribute, I should say, distribute first. Take the square root of 3 through the parentheses, see what you get. I want to see what you get for that. Bring the square root through the parentheses. We're going to try a lot of different problems. Okay, when I bring this through the parentheses, what do I get?
Square root of 18.
Square root of 18 plus 7 square root of 3, correct?
And 18 can be smaller, because that can go into 9 too.
Okay, and that's what I want to. Whenever I get a problem done, I don't want you to stop. A lot of people will stop at this step. So, well, I did what it said. It just said distribute. It didn't say anything else. I don't care what your problem is. I always want the answer simplified down. So when we do this here, we have square root of 18 is square root of 9 and square root of 2. Square root of 9 is 3. So we got 3 square root of 2 plus 7 the square root of 3. Okay? Now let's look at those two numbers. Are the radicals, in other words, the numbers underneath the radicands, right, the same? Then we can't combine them. That's my answer. If they're not the same, I cannot combine them. Okay. Now you can guess where we're leading to this. Okay? And when I say I want it in the simplest form, because it will make our next problems, after this test coming up, easier to do. Okay? Like I told told for other section today, I said, think about this. When you came to class, this day, 3 months ago, okay, and I asked you to solve down the equation, give me an equation that you could solve, right? Would the answer be like x plus 6 equals 10? Kind of, right? Now, 3 months later, I said, give me an equation you can solve. Now the answer is x squared plus 6x plus 10 equals 0, right? Get that squared in there, right? And now, once we get out this section, now we're going to solve down equations that are like square root of 3x squared plus 2x plus 6 equals 4. We're going to have squares inside the square roots. And that's kind of keep at it, right? Those are the best. I love those. Because you get to work a whole problem out, like a whole page long, and you get an answer and no solution. Down the front. It's like, that's the best. But, so, I like puzzles, so. Square root of 2, bring it through. Figure 5, bring it through. Bring it through. I did the first step, bringing the square root of 5 through. I'm going to get 2 square root of 5 plus the square root of 50. Okay? Looking at the first one, 2 square root of 5. Can I break that down? No. I said, okay, camera, I'm going to keep going. Square root of 50.
Can use 10, 5.
Okay, let's say 10 and 5. Okay, let's start with that. Now, what's wrong with that? You know? Does 10 have a square root? Does 5 have a square root? We don't want to use 10 and 5. It's a good answer. That's what a lot of people go with. What other ones could we use? Okay, 10 is 25 and 2. Would that one work?
Yeah.
Good. 25 and 2. 25, because the 25 has a 5 square root. So let's do 25 and 2. So we get 2 square root of 5 plus the square root of 25 and the square root of 2, right? Now we're going to have 2 square root of 5 plus square root of 25 is 5 and square root of 2. Now I said I could have got it the same, but it wouldn't be much. Here I want to break it down as far as I can. The answer, I can't combine 5s and 2s. Okay? Let's simplify.
Would you get the same answer with 10 and 5 though anyways?
Oh, 10 and 5, what happens here is this. If I went to square root of 5 and square root of 10, okay?
I'm talking about the factor tree.
Yeah.
Yeah, I was.
Oh, you're factoring? Oh,
Yeah.
okay. Then you would get the same answer.
Yeah.
Okay, I didn't, okay, factor tree, yes, you get the same answer, yep. If you went 10 and 5 and then you went 2 and 5 and did
Yeah.
factors, that'll work the same. Yep.
Okay.
Same thing. Back, my fault. I'm not gonna do the next step, okay? Next step. Foil. Foil. Put your guys a little bit here, a little bit here, keep going. Keep going. Let's see what you get. Then we'll talk about it. See what happens. Right after that step. Somebody who hasn't talked to me, can you help me? What is the square root? Don't simplify, but what is the square root of 5 times square root of 5? Nick? Don't simplify.
5.
What's 5 times 5?
25.
25. I'm not going to simplify right away. This is what I'm talking about showing work here. Square root of 25. Is it? 75? Okay. And it's positive or negative? Square root of 75. I'm just working with the numbers underneath there, right? All right. I know I could probably simplify a little bit in my head, but I'm just going to go like this. Negative 2 square root of 15 times square root of 5. What's square root of 15 times 5?
75.
Okay, and Nick added in the negative 2 to square root of 75, right? Because you got the negative, this times this, and square root of 75 and negative 2.
Negative 2 and 225.
Okay, negative 2 and 225. All right. Okay, well, I just multiplied the numbers, right? Boil it up. each one times each one. We're gonna do this, I'm gonna take it and then simplify it, add it together and all that good stuff, right? Some of you can look at this problem and say, square root of 25, Nick said it earlier, square root of 25 is 5, and I'm gonna go to the back one here. Megan, you have square root of 225? That one? Who knows that one? Square root of 25.
15.
15, right? 15, now you can see it right here. If you ever take a square root times itself, it just cancels the square off and you get that number. So you get 15 times 2. What's 15 times 2? 30. 30, so then that 30. Minus 30. Good. Okay? Now I'm going to do this in a couple of steps here. Now, what I'm going to look at is this. I got 1 square root of 75, right? And a negative 2 square root of 75. So I'm going to make that a negative 1 square root of 75. Okay? So now what I have is I have 5 minus 30. 5 minus 30. What's 5 minus 30? Negative 25. So I got negative 25 minus the square root of 75. Now, a lot of people got down to that root answer. And they said, okay, I did 3 steps. I must be done. Must be done. Now, simplify. Well, the square root of 75 has 25 and 3. If you did factor 3, you'll find it, right? So what I'm going to do here is this. I'm going to have negative 25 minus the square root of 25, the square root of 3. So again, negative 25 minus 5 square root of 3. Okay, square root of 25 is 5, right? Now can I combine those? Anyway, what, and how? Can I do it? One has a square root, one doesn't. I can't do anything with it. Not really nothing. Grand. A little confusing, but that's it. That is my answer. Did I make a mistake in here? Okay, try the bottom one. Try the bottom. On these problems, you kind of have to show work. I want to see work when you do them all. I know some calculators are nice and handy and doing stuff out, but everything has a two square root of 6 times square root of 6. Sound like.
2 square root of 36.
I know the answer is 12, but we're going to just write it down like this. We're starting 2 square root of 36, right?
And it's 2 times 6.
And 2 square root of 6 times 5 square root of 3. Don't be afraid to try.
You get 15 square root of 9.
I think you're one step forward. You can
Negative
at least
10
check.
square root of 18.
Negative 10 square root of 18. Okay, there we go. Negative 10 square root of 18. That's good. Then the middle term, I think, is the next one. Plus 3 square root of 3 times square root of 6.
3 square root of 18.
3 square root of 18. And then this one times this one. 15 square root of 9. Now, just multiply. I want you to just multiply the numbers there. Go through it that way. And then we'll simplify from there. 2 square root of 36. Square root of 36 is?
6.
6 times 2 is?
12.
12, so that's 12. I'm gonna look at here, I'm gonna just do this one. Negative 10 square root of 18 plus 3 square root of 18.
Negative 7 squared 18.
Negative 7 square root of 18. Let's simplify down, unless we know it. Negative 15 and square root of 9. Square root of 9 is?
3.
3 times 15 is?
45.
Negative 45, okay? Step by step. 12 minus 45. Negative 33. Minus 7 square root of 18. Okay, step by step. Now I think we're done, but square root of 18 has a square root in it. Square root of 9 and 2. We're going to break it down one more step here. Square root of 9 is? Times the negative 7 is? Negative 21. Square root of 2. And like I said, I like seeing steps. I like seeing the process of breaking it down one step at a time. I don't want to see, well, here's my answer. I want to see the process that I can see as you go. Okay?
I wonder if you're using a tree or whatever, like you break all the numbers down.
If it misses one.
Yeah, no, I don't know.
Which part did you get wrong?
I'm just like, I get to the part where like you get them all broken down and then you like combine them or whatever.
Yep.
So I'm kind of lost like, in that part.
Okay. So did you get 36 broken down?
Yeah, but like 6 and 6 and 3 and 2, 3 and 2.
Okay, so then the square root would be the 2's you group and the 3's you
Yeah.
group, right? So you would get out of,
3 and 2.
which was 6, right?
Yeah,
6 times 2 is
12.
12, that's where you get that.
Okay.
Now this one, did you break these down 18 separately?
Yeah, I broke that down.
So you would got a 3, 3, and a 2?
Yep.
And you group the 3's, right?
Yep.
So what you would have got different here is, the only difference on this step, I'm just gonna put an arrow on here, you're still gonna get the 12, okay? So in this one here, you're gonna get the 3 out, right?
Yep.
And 3 times the negative 10 is,
Negative 30.
so you're gonna have a minus 30 square root of 2 there, right?
Alright.
Plus now here again, you're gonna get a
6 or 3 and 2.
3, so the 2 stays in, right?
Yep.
And the 3 comes out, and 3 times 3 is,
9.
so you're gonna get the 9. Minus, and then over here, you did the,
3, just 3.
and 3 and the 15 is a negative 45, right?
Yep.
And so you're gonna get this answer, a little different answer, seeing the word, but now what happens is if you combine these two, you're gonna get a negative 33, and then you can combine these two, and you're gonna get a minus 21 square root of 2, which is the same answer.
Alright.
So you do get the same thing, it's just different way of doing it, that's fine. You're, right now, I have half seen it in the head, doing it with that, and some are doing factor trees. That doesn't bother me. Whatever you take to get the answer. It's kind of like this problem here. You'll see problems I got some on boards that are, you'll see problems on the board. They're doing different problems, but they're the same concept. And that's all I do in calc now is they come to class, they hit a board, and they do problems. I don't even tell what to do. But there might be 8 problems in here, and might be 8 different ways to do it. That's fine. You guys work with what works best for you. Okay? Next concept we're going to deal with is a little different now. We got so far, so good. Rationalizing the denominator. Rationalizing the denominator. We talked about rationalizing the denominator before, right?
We're just gonna do the same thing.
Kind of. Rationalizing the denominator before was you multiply by the same square root of the denominator, right? That's not exactly that. Now, when we rationalize the denominator where it's a plus and a minus like this, okay? We're going to multiply by the word they say highlighted in yellow up there is called conjugate. Conjugate is related to that factoring method that is the difference of squares. Remember the difference of squares factoring? Remember it's 2 parentheses, 1 plus, 1 minus, right? Why do we do that? Is because there is no middle term, correct? And what we do is we square the first 2 terms and we square the last 2 terms, right? But the parentheses look exactly the same except 1 plus and 1 minus, right? That's what a conjugate is. They're exactly the same, but one is positive, one is negative. So when we want to rationalize this denominator, what we're going to do here is this. We're going to multiply by the same thing,
that's in the denominator, except it's gonna be the opposite sign. And what we have to do is multiply top and bottom by. Multiply. That's why we practice our foiling first now. Now, gotta get a hint. When I said a second ago, when we do this, we have no middle term, correct? So really, we don't have to foil, because we just have to multiply the first two terms and the last two terms when we have both the same with plus and minus, right? Now on the top, I'm going to cheat a little bit. I'm going to go like this. That's my top for now. Okay? Didn't do a whole lot. Now the bottom. Square root of 5 times the square root of 5.
5.
It's 5. And now I think about it. This is one of the rules on this one I want you to really notice. If you take two square roots and multiply them together, they end up being if the same square roots, if their square roots are the same, it just cancels off the square roots. Okay? So like square root of 5 and square root of 5, the square root just cancels off and you can get whatever's underneath it. They're exactly the same. So square root of 5 times square root of 5 is 5. Okay? 1 minus, 1 plus, so they cancel each other off. Square root of 2 times square root of 2. 2. Square roots cancel off, so I have minus 2. Now, if I simplify it down a little bit, I'm going to have 6 the square root of 5 plus the square root of 2 over 3. Okay? Now, is there anything outside the square roots that are the same? 3 goes into 6 how many times?
2 and 1, so 2 is the 5.
Well, let's do this first. Take the 2, right? Then I'm going to bring the 2 through the parentheses. And so I'm going to get an answer of 2 square root of 5 plus 2 square root of 2. Okay? First I said 3 goes into 6 twice, right? Got that. Then I brought the 2 through the parentheses. Either way works. If you wanted to do this first and bring the 6 through, you can go 6 square root of 5 plus 6 square root of 2 over 3. You bring the 6 through first. And then you say 3 goes in all the numbers on the outside. So you can say that and get the same answer. Either one works. Okay. Do I have any square roots left in my denominator? No. No, I made this comment last hour. It kind of blew some mind at it. Think about it. Really think about it. Look at that first thing I got. 6 over square root of 5 minus square root of 2, right? That's a fraction. Correct? This is the same fraction. It's like saying 1/2 and 2/4 are the same thing. Correct? 1/2 and 2/4, everybody do that? 1/2 and 2/4 are the same. Just simplify it down. That's like saying this fraction and this fraction are the same. Because what did we multiply by? Same, we multiply top and bottom by the same, so we multiplied by 1. Are we changing the number any? No, we multiplied by 1, so therefore these two are exactly the same fractions. Don't look like it, but they are exactly the same fraction.
Are we gonna have to find out how to get it from the one state to the other?
To the back one, the first one, we will. We can always go backwards and forwards, all different ways. Okay? Question? Rationalizing the denominator. Okay, you try now. Rationalize the denominator. open the first step. Start off with is to multiply by the conjugate, which is the same thing. Opposite side, right? Same thing, but opposite side. Now, for the top, I'm just gonna leave alone, so I'm gonna leave it like this for now. That alone, right? On the bottom, denominator, first terms multiply together. Square root of 7 and square root of 7. 7. Square root of 49, which is 7, right? Now what's nice about multiplying by the conjugate, there is no middle term. Square root of 5 times the square root of 5. 5. Now somebody asked me first hour and said, how do I know what this sign is? It's 1 plus,
Negative.
and 1 negative, it's always going to be negative. Always going to be negative. Now, we got 4, square root of 7, square root of 5 over 2.
You can switch the 4 and the 2 to 2 and 1.
2 goes into 4 twice. We're going to cancel that off. Put 2 up here, so we're going to have 2 square root of 7 minus the square root of 5. And I can bring the 2 through the parentheses again and get 2 square root of 5. Okay? Bring it through. Question on that. Okay, so one more I want you to try. Rationalize. Multiply by the conjugate. Same thing that's in the denominator except opposite signs. Let's see some work. Start off. Like that. Correct? Now on top, we get square root of 5. I'm just going to leave it like this for now. Okay. Okay. Now the denominator. Square root of 10 times square root of 10. 10. Square root of 100, which is 10. You can FOIL it out. It ain't going to hurt anything. This times this is that. If you FOIL it out, you won't get a middle term. Square root of 5 times square root of 5. 5. I want to put 100 down there. So that's 10 minus 5, correct? So now I have the square root of 5, square root of 10 minus the square root of 5,
Plus square root of 5.
plus over 5, right? Got a few steps to do now. Can I bring the 5 and cancel these 2 off?
Not yet.
Okay. Now what we're going to do is we're going to bring this through the parentheses. Square root of 5 times square root of 10 is square root of 50. Plus square root of 5 times square root of 5 is, I'll leave it as 25 for now. Can we break those down? Square root of 50 is 25 and 2, correct? Square root of 25 is
5.
5, so we get 5. Square root of 2 plus square root of 25 is 5 over 5. correct? Now, what goes in all three terms? Five, so you get to go 5 out of everything, so 5 out of here, 5 out of here, and 5 out of here. Now this one's not gone, some people think that's gone. What I have left for our answer is the square root of 2 plus, and anything about itself is 1. So square root of 2 plus 1 is the final answer. Okay. Breaking down as you go. Page 603. 03. 4 through 48 by 4. Why don't you drop that whole section? Yeah, we can do that. That's great.
Are we turning any in or no?
Oh, what is that?
Are we turning any in, Mr. Fisher?
Was that?
Are we turning any in or no?
Not this time.
Do you have my notes?
What? She said $1,000 from Best Buy.
Yeah, that's the tax.
Oh, that's cool though.
It's like, that's our order, we have to do things like $50,000 like really hard. I tried it or something. What was wrong with that one? Was there like a speaker or anything?
Don't, Megan, don't click on the link.
There's a link, don't click on it.
Yeah.
Is there a link?
Yeah, and for the receipt.
It's spam.
Megan, I'll have you enter your credit card.
Yeah.
Safekeeping or something. Every single time you take your Fisher out, charge $10 a month.
What are we doing after?
On this one, you times the 2 by 8. So that 8 is
That's hard.
Yeah.
Let go, it dropped. Broken screen. Get my sheet.
Yeah, the one that I gave you yesterday to do today, that goes right here.
So like, oh, like there was the spending, go back to the, so it's